Good afternoon, everyone. I'm super excited to be here with you today to talk about how you can build a future-ready security operations center with AI by transforming your security log into OCSF format. But before we begin, please welcome my co-presenter, Alan Umandab, Director of Public Cloud at Merck, Pratima Singh, Senior Solution Architect for Financial Services and Insurance at AWS, and I am Sushavan, Senior Technical Account Manager for Healthcare and Life Sciences at AWS. Alan and Pratima will be joining us later in the stage to talk about Merck's story and a cool Agentic AI demo. Thanks, Alan and Pratima. Now, before we get into an agenda, let me ask you something interesting. What if I told you that you could reduce your incident response from a full day analysis to just 30 minutes, or maybe even lesser? Please raise your hand if that sounds too good to be true. All right, I can see a couple of hands. Well, let me tell you, Merck did exactly that. And today I'm going to show you how you can achieve the same outcome at your organization using OCSF. We will first discuss about the common data challenges you face with a different log source, with a different log format. Then I'll introduce the Open Cybersecurity Schema Framework, in short, OCSF, as a solution. We will hear Merck real-world story about how they have transformed their central logging using OCSF and how they leverage OCSF together with generative AI to slash their incident response from a full-day analysis to just 30 minutes. And finally, you will witness the power of OCSF with a cool Agentic AI demo. See firsthand how you can revolutionize your security operations center with OCSF and AI. Now, before we begin, let's establish a fundamental truth. Security is fundamentally a data problem. The challenge is not about lack of data, it's making sense of the data you have. Now, let's look at modern enterprise security landscape. You're no longer managing just one environment. You have your on-premise data center, you have workload distributed across multiple cloud providers, and then you have a vast ecosystem of a SaaS environment. Now let's imagine your security team is trying to investigate a potential breach, but your firewall log sits on-premise, your endpoint data in a different application, and your cloud data is scattered across multiple cloud providers. To investigate, they need to navigate 3-4 different systems which are having a 3-4 different log format. And remember, it's all just for one investigation. Your analysts become digital archaeologists, spending hours just trying to piece together what happened. Meanwhile, the real incident slipped through the cracks because you can't see the full picture. But here is the reality. Your best security engineer, the one who should be spending time building advanced threat detection algorithm, are instead writing endless data parser. That's because every system speaks a different language, different field name, different structure, different timestamps. Hence, they're mapping field A in system X to field B in system Y over and over again. Every security tool you introduce means another complex data pipeline to be managed, another custom parser to be built. It's like having a Formula One pit crew spending their whole day organizing the tool instead of changing the tires. What if you could change this? Let's have a system who would do all this undifferentiated heavy lifting or doing the data transformation to create one single universal data format so that your security engineer can focus on what it matters to them most: threat detection and response. The next challenge is the data tsunami, and it's real. Every application, every network devices, every endpoints are generating more logs than ever before. Sounds familiar, isn't it? But here's the kicker. It's not just a more data. It's a more different data. Hence, you're drowning in information, yet starving from insight. Your detection systems struggle to keep up, so as your budget for storage and compute power to process this huge volume of log. So what's the solution of all this data chaos we talked about? Meet OCSF, the Open Cybersecurity Schema Framework. It's open source, take away all the nuances of a proprietary schema, and it's not just a simple schema, it's a framework to render the schema. This isn't generic, it's purpose built for your security team. And irrespective of the source event, OCSF will always maintain the same data structure. You can customize it and extend it based on your own needs by keeping the core framework intact. And this is my favorite. OCSF is a source agnostic as well. So whether your log is coming from a third-party vendor or AWS platform level logs, OCSF will always create one single universal data format. And because it's a universal data format, OCSF will always provide same structure, same field name, same query path for your security tool to consume. Now let's see OCSF in action. This is where the magic begins. On your left-hand side, you have your event producers, your security tool, your application, your network devices. Each one traditionally speaks their own language, creating the data chaos we talked about. OCSF sits in the middle, acting as a universal data translator. But if you're wondering whether you still need to do the mapping between your event producer on the right to the event consumers, the answer is no, not for AWS platform level logs. Amazon Security Lake does that for you. Remember the system we wished before? The one who should do all this undifferentiated heavy lifting of doing the data transformation to create one single universal data format? Here you go, Amazon Security Lake for you. So now, on your right-hand side, your event consumers, your SIEM, your data lake, your analytical application, your AI/ML workload, they're all going to receive the data in a same consistent format. Not just that, you pay less for your storage as well, because Amazon Security Lake stores the data in a Parquet format, which further compresses your OCSF formatted log data. You pay less for your compute as well. You know why? Because Parquet, being a columnar format, inherently provides a better query performance. So your Athena query would run much more faster than ever before. Lesser time to execute a query means a lesser compute power you're using, which translates to a lesser compute cost. Now, before I explain you the key benefits, let's try to recap the data challenges we talked about and see if this key benefit can address all those data challenges. First, as I said, OCSF creates as one single universal data format that makes you ready to operate in a hybrid cloud and multi-vendor environment. So no more visibility gap that you had with a different log source, with a different log format. It's a one-time mapping at the producer level. That means you set it up once at your producer level, not for every security tool it consumes. No more custom parser required at your consumer level because you already did it at the producer level. That eliminates the need for you to have that complex data pipeline we talked about. So now you can optimize your security talent in a much more strategic work rather than doing the data transformation. And finally, and most importantly, it's the AI/ML ready. So a Gen AI model can work on a clean, consistent data, turning the increasing log volume into a valuable insight. This is how you break down your data silos and supercharge your security operation. Now let's hear from Alan how Merck has transformed their central logging using OCSF and AI. Alan, over to you.
Thank you, Shushaban, for providing the background and introducing the challenges that we can solve with OCSF. Good afternoon, everyone. I'm Alan Umandap. I lead the public cloud platform team in Merck. I have been with the team for more than 10 years. It's always been our mission to provide an environment to our customer by delivering or enabling key technologies, critical technologies to support the business needs. Through this process, we were able to support secure cloud environments to our user, which is actually capable of supporting the whole technology life cycle. Our team believes that the path to production should be a happy path. It's our goal and mission to ensure that the path should be the easiest. Maybe you're wondering how we are able to do this. It's through our self-service offering, providing access to the data in our central logging environment, and also providing clear guidance to our customer. Now, let me tell you about our company, Merck & Co. Inc. also known as MSD from outside United States and Canada. We are a global healthcare company that provides innovative health solution through our medicines, vaccines, biologic therapies, and healthcare and animal health products. Our heritage speaks to our commitment. For more than 130 years, we are able to, provide humanities, provide hope to humanities by development of important medicines and vaccines. This is not just our history; it's our ongoing mission. Sushiban gave us a very nice background about OCSF. But I hope that from my presentation, that you will gather enough information for you to evaluate and use, OCSF for your own purposes. And also, with this diagram, I want to explain how we are able to, do our transformation journey to OCSF. By the way, is this diagram very familiar to you? For the architects and engineers in this room, if you have deployed and designed an AWS, multi-account strategy, this diagram should be very familiar. Every landing zone, every successful landing zone that is deployed, in my experience, would benefit from having a central logging environment. A central logging environment is a setup that helps you collect the logs from multiple accounts in multiple regions into a central accounts, which in a central account, which help you for the purpose of monitoring, analysis, and auditing. Now, let's see how it works. From our AWS managed account, we have a cloud trail that is set up to send the logs into our central logging account in the S3 bucket. From our application accounts, we have the AWS swap logs and flow logs also configured to send the logs into our central logging account. And our customer would then able to access this data so that they can generate their own analysis and insight. Well, this setup actually performs very well, and it meets our key compliance requirement. However, we also do recognize that there's actually room for improvements in simplifying this process. With the opportunities like this to simplify the process is basically we wanted to reduce costs, reducing time to spend in operational overhead, so that we can shift our focus more on strategic platform initiative. So how are we able to achieve this? Well, there are 4 key factors. From the business perspective, first we look at opportunities to accelerate our rapid incident detection. Rapid incident detection, improving our response to activities that are related to security and operation would help us react much faster and protect our critical infrastructure quickly. We also wanted to improve our customer experience by enabling AI ML capability, modernizing and building our infrastructure to be ready for AI and ML integration. Help us position us to leverage advanced analytics to derive business value quickly. Now, from the IT perspective, we wanted to optimize the cost of running our central logging environment. So we look at areas in reducing our storage costs while also streamlining our processes. From the operational efficiency, we wanted to shift more in using managed services. As you have seen in the previous diagram, for us to continue using our central logging environment, we have to set up and use many AWS services. This actually creates a lot of operational overhead for my team. We wanted to shift that overhead back to AWS. Also, you might have experienced that as you increase your AWS usage, the amount of data that you are generating also increases. Well, the increase in data create a lot of inefficiency in using the data for query and processing. And another factor that is affecting this is that all these data are actually in different log formats. Okay. So how did we, able to achieve our transformation? So back in Q3 of 2024, we done a comprehensive assessment of our capability, looking at capability and value in its value, looking at capability and its value of the central logging environment, and then to do this, we work closely with our AWS partners by asking and giving us strategic input and key best practices. Back in Q1 of 2025, we started. Back in 2025, we started our planning. Our team actually lead the deployment planning, and together we were able to create a plan that we can execute that have optimal central logging capability. In Q2 of 2025, implementation actually started. We selected and implemented AWS Security Lake, and immediately gained the benefit of having transforming our data automatically into OCSF. We also are able to do some measurement in real-world performance against our expectation. Now, in Q4 of 2024, we wanted to shift our focus in finding more opportunities to leverage our modernized central logging environment with the OCSF normalized data. We look for use cases that can unlock AI capability so that we can use it for other purposes within the team. So this is the modernized central logging environment with OCSF that we have built. As you can see, the application account still generates AWS CloudTrail, VPC flow logs, and WAP logs. But I think the key difference now is that we are using Security Lake and actually automatically transform our data into OCSF format. Now, now from our central logging environment, our user is able to access the data and use it to to generate insight and insight and run their analytics. The shift to managed service approach gave us an added benefits of not only converting a lot into OCSF, but also created significant infrastructure, cost saving, and operational efficiency. Moreover, we now have a modernized central logging account with an AI-ready data. So how did we achieve the operational efficiency gain? With all these changes, we have seen a 48% reduction in time that we are spending in managing a central logging environment. Nearly half of the operational cost has been reduced. Now imagine what this means to our team, right? Now our team can now focus more into strategic, strategic initiative. So how did we achieve the 40% efficiency? Well, there are actually three driving factors. First, rapid enablement. With us shifting our focus from managed service and doing more evaluation and testing of built-in features and reducing our time in creating new features, we are able to remove the time spent in creating and enabling new features, improving our central logging solution. Central logging solution was reduced from weeks to just hours. Now, there's also reduced operation overhead. With the heavy lifting of the log transformation is done by Security Lake, we actually able to eliminate custom code that is used for log processing. Also, the access to the data for our key stakeholders, and now we are not able to do that from Security Lake. Lastly, ready to use. With the data getting converted automatically to Security Lake, the access to data is self-service. Immediately, our user is able to access data to generate analysis and run insight and create insights. Now, with the infrastructure, the benefits actually extended beyond operational efficiency to significant cost saving. The infrastructure cost that we have generated is about 47%. The normalization of OCSF within Security Lake actually reduce the infrastructure cost by improving data storage, processing, and analysis. With the data coming from the application team automatically being generated to OCSF and stored in Parquet format, it actually provides several cost-saving benefits. Now, what are the driving factor in generating the 47% cost savings? First, there's managed service. With us moving to AWS Security Lake, we actually benefited from AWS economies of scale. With this, we don't need to actually build and maintain custom infrastructure, and we actually was able to decommission our central logging environment and reduce our total cost of ownership. And OCF normalization, well, the standard schema eliminates standard fields before storage. The standard before storage. The OCSF efficient structure, well, within Security Lake, it was able to store the data once, eliminating the need to store it multiple times in different log formats, basically reducing our storage footprint. Now, for the compressed storage, with the scale of how we operate and the data that we are generating, with our OCSF normalized data being stored in Parquet format, we actually create a lot of storage costs because of the exceptional compression that actually provides. And lastly, reduce compute. With the data, being partitioned in columnar data, our Athena queries run more efficiently. With these four key factors, managed service, OCSF normalization, compressed storage, reduce compute through efficiency of our query, we're able to generate that 47% savings, which we can actually use to invest in other innovative solutions. Now, let me shift the focus from us generating infrastructure costs to generating operational insights to a more, I would say, interesting activity that we have done recently. So after we deployed Security Lake, and access our data, we are able to work again with our AWS expert to explore a POC that actually use our logs for security operations. Our goal was really to test if AI can help us, investigate security incident more efficiently. So with Agentic SOC AI prototype, what we have to do is only give it the, activity, the WAP record ID. What it does, it was able to generate a comprehensive report or insight in less than 5 minutes. It actually analyzes the traffic and request pattern. Look at the sources, including providing the IP addresses. Look at behavioral, look at the behavioral conditions, and then created a very nice report that provide actionable recommendation. The AI findings. The AI findings that we have generated in here was only possible because of the OCSF with the standardized schema. The AI was able to correlate security context, threat intelligence, and infrastructure context, quickly, generating this report in under 5 minutes. With the security, from the security perspective, operation perspective, this represents the fundamental enhancement, AI-driven threat analysis that can empower teams to investigate quickly, faster and effectively. Is really better than any manual way of doing things. Now, let's look deeper into this process. So in the past, investigation is really very manual. So my team would usually derive concept from historical record. We would need to learn and translate different log formats, develop complex query, and using that complex query against unpartitioned raw data usually results into a long execution time. And then when the output when the output is given, we have to translate it into a more meaningful information. But with Agentic SOC AI, with Agentic SOC AI prototype, the orchestrator was able to coordinate with child agents, basically performing the same manual step that we are doing. But now it can automatically get the context from historical records, it's able to quickly analyze logs because they are in OCSF format, develop optimized query and run it against OCSF normalized data, which is also stored in Parquet format, resulting in a very nice human readable insight. So I've shown you how we can generate security insights, but now using OCSF. But now we can also do that with operational operational insight. Right after production, one of our customer actually reached out to us and reported a spike in their cost usage. Our engineer was able to use AWS MCP servers to query our data. But remember, with OCSF having this standardized schema that applies across several AWS services, we are able to generate that information very quickly. I think without OCSF universal format, we would have spent hours in stitching together all these logs and finding that specific relationship and to determine the root cause. By the way, the root cause for this one, in less than 5 minutes, our AI was able to determine that it was due to a spike in KMS decrypt data events because the S3 data events was actually enabled. So with all these changes that we have done, with modernizing our central logging environment and normalizing our data into OCSF, we were able to generate infrastructure savings, operational efficiency, and also enable us to explore more AI capabilities. This actually generated a lot of interest for my team. As our next step, we're actually going to put more time to find more opportunities to increase our efficiency, reduce costs, and explore more AI capability. Now, for us to learn what an OCSF can do when it meets AI, advanced AI, I will pass it over to Pratima. Pratima?
Thanks, Alan. So you heard from Alan how a single standardized framework has been pivotal in accelerating incident response, essentially reducing the time to detect and respond. When we look at OCSF and when we look at an agentic AI solution, what is most important is the context window of your agent. Now, when you're dealing with different types of log events, when you're dealing with different diverse schemas, when you're dealing with different attributes that need to be correlated, the AI agent's context can grow and shrink depending on the information that it has to process. And that can result in differentiating responses depending on how much information it is going to produce. When we look at an unambiguous and standardized framework like OCSF, it makes it easier to just load up that open source code onto the agent as a knowledge base and be able to guide the agent to learn from it. So OCSF provides that distinct value in the age of agentic AI. Now, how many of us have heard about OCSF before coming to this session? You know of OCSF? There's a few hands. I'm going to give you a very small, like a quick start into OCSF. And if you want to ask more questions, we can talk more. We can do it after the session. So at the core of OCSF is an attribute. An attribute is a key value pair. It has a key that identifies the information that the log event is presenting and a value that captures the information that the log event is sending through. Now, a collection of related attributes forms an object. Think of an object as what you would do if you were programmers. It's the atomic unit that defines a collection of attributes that define a thing. Now, a collection of objects becomes a class. A class represents a single log event. Now, you could have multiple different types of sources emitting different types of log events. A single source could emit various types of log events that match up to different classes. For example, if you look at AWS CloudTrail, it emits authentication activity, it emits API activity, and it also emits audit activity as a different class. But if you look at, say, SSH activity coming through an EC2 instance when you're SSHing into it, it's a single standard log. It is SSH activity that falls under a category called network activity. Now, a collection of multiple classes is what we call a category, and they're all related. So you would never see an authentication activity falling under a network activity category. It'll be SSH, TCP activity, HTTP activity, FTP activity. So everything related to what network resources or network sources could be generating. Now, OCSF is designed with the goal to be an open standard that is adaptable to any environment, any solution, or any application, while still complementing the existing security controls at hand. So you're not diminishing any value that you already have in your environment. Now, there are 2 sources of logs there. With the show of hand, tell me if you're able to identify where each one is coming from. There's one, half a hand there. Well, if you look at it, these are sources of logs coming from WAF and VPC flow log. Now imagine you are positioned in a scenario where you have to find an indicator of compromise, for example, an IP address that is traversing your network stack. So coming through layer 7 all the way to layer 4. The first thing that you have to do is make sense of that one standard out line that the VPC flow log is emitting. So you would make it JSON parsable. You would add attributes to capture the values coming through the VPC flow log. And then you would have the capability to correlate them and generate some sort of business value or what you're trying to do. Now that is the kind of data wrangling that you have to do today with raw log sources. Kind of reminds us of what Sushovan was talking about earlier when it came to different data types and data volumes. But now if I translate this all and map it to an OCSF class, what immediately grabs our attention is how consistent the log schema is. You will find a source IP address in exactly the same location in a WAF activity log and in a VPC flow log. All you need to remember is which table that information is collected in if you have a data lake where all the log sources are going. So you can see the source endpoint IP is exactly where the IP address will be. And what's more important is OCSF is quite opinionated in data types. So an IP address will be of the data type IP address. An AWS account ID will be of type string, not a big int in some log source and not a string in another log source, so you have to do data type transformations. Another value add is OCSF is customizable. So you can use the construct of observables to surface certain common values that you use more often than not to correlate and grab information out of. Now that means that you become completely immune to the log sources under the hood or the object or the entity that's emitting the logs. All you care about is what activity are you trying to track or what values are you trying to correlate. Was that primer good enough? Because we are now going to pivot into a typical triage scenario. So how many security operators here? People get paged, there's a security event, oh my God, I have to wake up at 3 a.m. Right, so what do you do the first time you get an alert? What do you do? The first thing you do is you try to figure out, what am I supposed to do with this alert? You have runbooks, playbooks, or nothing, and you try to figure your way out. The next thing you do is you establish why you should care about that alert. Is it worth waking up at 3 a.m. at night? Maybe it's the production environment and I have to, but if it's a sandbox environment and some devs decided to test after, a big game night, then you probably don't need to respond just yet because you know it's a quarantined environment. It's not going to allow for lateral movement, so you can pass it on. So that's the business context that drives the rate of or the speed of response that it needs. Once you've established the business context, you want to understand who did what, where, when, and why. And that's the meat of everything, the log analysis of what is happening in this environment, what am I supposed to do once I've established what's happening in this environment. And then finally, has this happened before? Because it could have. We have historical evidences that we store through our ticketing systems, through our backup systems, and we want to establish whether this thing, if it was to happen again, what are the steps that we need to take? Now, when we put all of that into an agentic AI scenario, we can split all of these up into different agents. OCSF gives you a customizable, unambiguous, and consistent way of operating on these logs and enhancing that log analytics workflow. Now we'll break it up, because there's a demo coming up after this of what this particular flow will explain. So we'll break it up. Say we say the orchestrator is the security operator, right? The first thing that hits the orchestrator is the alert. It needs to figure out, what am I supposed to do in this case? Where is my runbook? Where is my playbook? Imagine an agent that sprawls out into various sources of data in your environment and figures out where the runbook is. Maybe something relevant to an application that's in the picture, maybe something relevant to a resource that's in the picture. Once it has the runbook, it wants to establish what is the business context for this particular alert. The resources in these alerts, why are they important? Or what is important around them? They could have permissions to confidential information, and I need to trim it right away. Or they could be a sandbox environment, have dummy data, and maybe this can wait for later. So the orchestrator now triggers agents to retrieve business context. Once it has the business context, it's going to look at that contextual information and trigger log analysis. Now, log analytics is one of the most human-intensive tasks in an incident response scenario. When you think of it, the amount of time you take to analyze logs can either add or reduce time to respond. And such kind of human-intensive, very repeatable manual tasks are prime candidates to be handed over to an agent so that you as security operators have time to innovate, build better agents, think of better playbooks that are more interpretable by your orchestrator. Once you have the log information, it can interpret it back with or correlate it back with the business context that it received. So imagine you as humans having to go through lines of logs and then trying to figure out this context I saw somewhere, or trying to figure out where did this account come from, where does this IP address come from, and doing all of that while you're pushed to respond faster and faster. And of course, save the investigation history. Try to figure out how we can make this information readily available the next time something like this happens. Seems simple enough. This is kind of what you would do in a security operations scenario. Now, when we put this into perspective with Merck, we built a proof of concept with them to dive deeper into AWS WAF logs. So as a demo, what I did was I deployed a demo application and I loaded it up with a distributed load test. And it had about 10 million requests that were blocked by the WAF. But think of 10 million requests if you had to look through WAF logs and you had to look at each of them, whether they are blocked or whether they are allowed, and you had to put filters into place, put Athena queries or whatnot, the amount of time that would take, and when you're operating on raw logs. So here I have one orchestrator. I do not have any investigations right now, so I don't have any investigation history. I have the one orchestrator. It has 3 agents. Those 3 agents are basically available as tools: the log analytics agent, the business metadata agent, and the historical evidence agent. Now, the first thing I do is I tell it, hey, AWS WAF has detected some activity that's happening, suspicious activity, in a said AWS account. I give it no further context. I don't know what this account means in the bigger scenario of my AWS accounts, and I also don't know what activity the WAF has detected. I just know something's happening. So the first thing the orchestrator does is it triggers the playbook agent, because it needs to work out, what am I supposed to do? It finds out there is an account ID in play, I'm looking at WAF and I'm trying to do something, so it's then subsequently going to trigger 2 more agents. It's going to say, I need to find the business context of that account ID because that's all the resource I have through this alert. Is it important? Is it not important? And I also need to find out what happened, where, when, and why. Now, slowly and surely, it does look up the backend. In my case, I've just loaded up values in a DynamoDB table. In your case, this could be an MCP of your CMDB. You could connect it back to your agent. Now, it completes its analysis, and it tells me, I know what's happening here. This is the account that you have asked me to look up. It gives me all of the information of the AWS organization. It tells me the business criticality. It tells me the data classification. It tells me who I should be talking to if something happened in this account. And this is all coming from information that you today have. And then it looks up everything that happened in our WAF. It tells me I see 10 million lines of code, log, and I see that they were all blocked. There is suspicious activity happening. This is a DDoS kind of event. It has been rate limited, and it presents recommended actions. Now, mind you, I haven't had to train my agents to do any of that. I have just put a prompt in that says, look up the WAF log activity and tell me what I can do here. And look it up for like 3 hours, right? Because you don't want to overload the context window as well. And it summarizes it into a small investigation history that then goes back to my data store as investigation history. Because the next time I trigger this agent and I give it the same account ID, it doesn't even need to look at the playbook agent, because it knows through historical evidence that this account ID is meant to have the same metadata that I looked up in the last event. And we did something interesting to capture the cost for that particular investigation and how many agents are triggered and how many tokens are exchanged. Now you can see this all happened in a matter of a couple of minutes. imagine yourselves on the other side of the computer trying to do this. You would take, if not minutes, at least a couple of hours to figure out what's happening and draft out that investigation history. Now, all of this is powered by OCSF under the hood. My agents were able to interpret OCSF straight out of the box. They did not hallucinate on the different types of log schemas coming through because they knew exactly which log schema they were working with, or the framework rather, and they understood that it was coming from the log, the WAF log, and they understood what it means when we talk about WAF log activity. So it was pretty simple to build this proof of concept. The OCSF community, having realized these values of versatility, adaptability, has been growing since Black Hat 2022 when it was first introduced. We have about 1,100 plus partners who are supporting it, 200 plus organizations that are using it. If you scan the QR code on the top, that's the open source Slack channel for OCSF. If you have any questions about OCSF, ask the contributors right there and then. You can talk to them. They have calls that you can ask to get added if you want to listen in. The second QR code is for Amazon's OCSF-ready specialization partners, which we recently released, which means these are partners who have established their technical ability to consume OCSF logs that are produced by AWS services and build solutions on top of it. So if you're restricted with the number of people in your business who would be able to do this for you, you can leverage these partners. Now, as with everything in technology, and a lot more accelerated with agentic AI solutions, everything changes all the time. When we built this solution, Bedrock Agents was our backend. Now it's all agent core. So think about how you can innovate by using agent core that gives you a completely secure environment to be able to build agentic solutions. It's completely managed, and it uses constructs like identity and gateway to be able to build isolation between the agents as well. Think of how you can add additional agents. What would benefit your business? What are the bespoke items in the incident response lifecycle that you would need agents for? And they could be different to what I've shown you. This is pretty much a generalized use case. Think of MCP integration. Now, there is reason why you may not have everything stored in your AWS accounts. You could be using third-party accounts or third-party services. You could be using certain identity services, certain response services. You can use MCP to integrate all of those solutions into this particular environment so that it does feed off of that information. And if you use AWS, Amazon's OCSF-ready partners, you're able to then consume OCSF out of the box. And when we built this, Amazon Quick Suite wasn't a thing. So Amazon Quick Suite gives you a completely managed interface to interact with your agentic AI solution. So you don't have to build a front end anymore. You can just hook it in through your MCP integrations with Amazon Quick Suite. So the key takeaways from this session is keep learning more about OCSFs, see how OCSF can give you value with your log analytics use case and your security operations use case. Learn more about agentic solutions. There's an agentic AI learning resource that I've linked there. And we've recently, or in fact yesterday, so we released the AWS MCP server, which is a managed interface into the AWS API MCP and the AWS knowledge bases, which can then help you build agents that can directly remediate resources within your environment. So you can use that to remediate lower order environments automatically, and then put like a human supervision or an approval workflow to remediate production grade environments as well. I hope you learned something new today. Thank you so much for attending our session, and please leave us feedback on the session survey in the app. Thank you.